Good evening. What did we do on Thursday?
Definition of derivative practice, I think.
And it was pain in the ass.
And we did the little triangle thing.
The little triangle thing.
Well, the big triangle.
You've now just insulted. You've just insulted Pascal.
Pascal's little triangle. We
Just insulted Pascal.
Put all that work to making the triangle infinite become a little.
Well, now we're going to start looking at taking derivatives without actually directly passing through a limit.
For sure.
All of these derivations, I believe all of them, are in the textbook. Read through the proofs. First up, the constant rule. Derivative of a constant is 0. I mean, just kind of think about that logically, it makes sense. What's the derivative representing?
The change.
Change, right?
Constant.
And constant doesn't change, that's why it's called constant. So it has no change, so its derivative would be 0. Power rule. Starts off with just positive integers. If f of x is x to the n for any positive integer n, then its derivative is n x to the n minus 1. And I believe it is in here later where it's more generalized, where n can be any number. But you just bring the power down and subtract 1. Some difference constant multiples, or scalar multiples. So consider two differentiable functions, f and g. Let k be a constant. The derivative of f plus g is f prime plus g prime. So derivative of a sum of the derivatives. Oh, but guess what? Subtraction is addition. So derivative of a difference is the difference of the derivatives. Right, again, typically this will be put into one rule called the sum difference rule. No good, it's not my screen. Why is that at all? Oh, it's J prime. I thought that was F. Okay, that's a J. And then you have your scalar multiple rule. The derivative of the scalar multiple of a function is just the scalar multiple of the derivative of that function. Now remember when we studied limits, we had the sum law for limits and the scalar multiple law for limits? And I said those two properties taken together were the linearity properties. The derivative is linear. Which again makes sense, right? Because the derivative is a limit, right? So that's what? Sum, scalar multiple. So that allows us to do any kind of polynomial, right? Because polynomials are just sums of power functions. What do we think? And you've already spoiled my fun once, so I'm watching you really closely. What do you think the derivative of a product of functions will be? You put your hand down.
Sorry, repeat.
I have a heavy tumbler, I'm not afraid to throw it. Derivative of a product of functions. What do we think it is?
You take down the power.
That's the power rule. Right, so we had the derivative of f plus g was f prime plus g prime. So So derivative of a product, derivative of f times g. You think, based on this logic, no, it's just f prime times g prime.
Oh, it's the F.
Don't ruin my fun.
Fine.
If you actually know, don't ruin my fun. I would throw my Sprite bottle away. I want that. I'll just hope the tumbler ricochets back to me.
Or I can't turn the correct, so I'm sure it's all.
F prime times g plus g prime times f. This is the product rule. Which actually isn't too bad. The f prime times g prime we call the student's product rule. This is what students want it to be. But what about f divided by g? The quotient of functions. Well, now that we've seen the power rule, would it be smart to say f prime over g prime? But that's probably not true. That's the student's version. Quotient rule. F prime times g minus g prime times f all over g squared. Wait, that's still product. Why? Oh, it's giving it a more. There's something wrong with this other slide. What's going on? Let's fix that. There we go. There's a question mark. G times f prime minus f times g prime all over g squared. Quotient rule. Keep in mind that with the power rule, since it's addition, the order doesn't matter. Right? Whether you do g times f prime plus f times g prime or g prime f plus f prime g, that order doesn't matter. With the difference quotient, it does. Or with the quotient rule, rather, it does, right? Because it's a difference. Extended power rule, if k is a negative integer, you have the same thing. They don't have for any power. I wonder if that's in a different section now. Those are the constant. Is that even really a rule? Give it a half. So we have the power rule, sum, scalar multiple, product, quotient. We have 5.5 rules. Constant rule, don't give it half status. Let's start calculating derivatives. without limits. We don't make you pass it through a limit to verify it. So by the way, now on the test, which I did write the second test, I just finished writing it this morning. Unless it tells you to use the limit definition, you can use any of the shortcuts. F prime. So I'll break this one down.
Bless you.
Some difference, right? Using some difference rules. Well, that first one is going to be a scalar multiple. Second one's a scalar multiple. Third one's a scalar multiple. Well, now we just have it as a bunch of power functions. So power rule. Derivative of x to the fifth by the power. 5x to the 5 minus 1 again. I'm just going to break it down this way for this one problem. Derivative of x squared, 2x to the 2 minus 1. Derivative of x by the power rule. It's an implied power of 1, right? So 1 comes down, x to the 1 minus 1. Nope. Hardest derivative of the whole semester. What's the derivative of 9?
0.
9's a constant.
What we need to show all these steps.
No, I'm just doing it to show off how the rules work.
Okay.
Derivative is 35x to the 4th minus 6x plus 4. And I leave it to you to pass it through the actual definition to confirm it. Oh, that's only the first derivative. They also wanted second derivative. Which remember is the derivative of the derivative. 6x plus 4. I'm not doing that breakdown again. Go term by term. X to the fourth. What's 35 times 4?
160.
140.
140. X to the reduced power by 1. Oh, this one's tough. It's just 6. Oh, this one's even harder. 0. Done. That was your second derivative. I'm going to change that to say k is a rational number. Can be all real numbers. The proof of this, however, requires a bit more work, so that's not proved in this text book. I think you have to use Taylor series to prove it. So you may also see this notation without the parentheses. It means the same thing. So what you're going to have to start getting used to now is the idea of a mathematical operator. Right, so by the way, you've been working with operators. Plus is an operator. If I just write that, dvx, that makes no sense. Much like that makes no sense. So dvx has to be operating on something. So that makes no sense. By the way, that would make no sense either. Remember, that's just f prime, right? Two ways of representing the same quantity. Right, now we'll go term by term. X to the 1/2. Power is a half. Bring down the power. Multiply by 3. What's a half minus 1?
Negative 1/2.
Negative 1/2. You're jumping the gun. Five x to the minus 2. What's the power?
-2.
Bring it down. Negative 2 minus 1.
-3.
Last one. What's the power?
-3.
Multiply by 7. Negative 3/2 minus 1. 5/2.
-5.
Yeah, pleasure to. Could simplify that. I really wanted to. General rule of thumb. Look at the form in the question. Leave your answer in the same form. It gave it to me non-simplified with negative exponents and fractional exponents, so I'm leaving it with negative exponents and fractional exponents. So you're paying attention. What's the form of the tangent line of a function at a point A? Oh, I'm feeling so generous. I'll start it off. What is it? Be more specific. Remember, this is a tangent line.
F prime of x plus x
F prime what?
of x
F prime of A.
times x minus a.
I agree with the times x. So there's your mx. What's b? I did derive it in class. I think it was last Tuesday.
Would just be F of A.
Not just f of a.
That's why equals F of A.
I agree there is an f of a in there. So I do agree there's a plus f of a. But there's still one more term.
Dot X minus A.
Well, that's for point slope form. I expanded the You got 2 out of 3. So I'll just reduce everyone's test 1 score by 33%. Technically 33 and 30%. You agree with this one, by the way. No, not yet. Yeah. No, not yet. It's coming up. It's coming up in my docket. There's f of x, right? So we want y prime. What's y prime?
3 F X squared 1 half.
So the tangent line y equals y prime evaluated when x is equal to 4. That's what a vertical bar means. Times x. Plus f of a is just y evaluated when x is 4. Minus 4 times y prime when x is 4. Doing this also to show off that notation. What is y prime at 4? What is y at 4?
Eight.
Is it 8?
And we just said what y prime was, right? 8 minus 12. There's your tangent line. Y equals 3x minus 4.
Just a question. How do you do that?
What's 4 times 3? All right, so let's look at the function x cubed plus kx, where k is an arbitrary constant. Find the value of k so that the slope of f of x at the point x equals 2 is 6. Well, what is slope of f of x given by? What's f prime?
3x.
We're told we want the slope at 2 to be 6. Plug in 2. What is f prime of 2?
Okay.
That has to be 6. Solve for k.
-6.
There's your value. By the way, what does a horizontal tangent line mean?
When n is 0.
So in the case of tangent lines, what is slope?
Oh, the a, the f of a. The
Not f.
It's like a local maximum.
What is slope of a tangent line? Derivative. So f prime is 0. Slope is 0. Vertical tangent line. F prime of x tends to infinity. Again, notation. We'll write equals, but technically speaking, equals infinity doesn't make sense. So that is implied to be a limit. Find f prime. So when you get really good at this, it won't take you long.
Which multiply by -3 at the top. And subtract by 1.
So what would be?
So it would be -12 over -12 over x squared.
X to the fourth,
Oh, it goes up.
because it's in the denominator. So instead of trying to do this in our heads for right now, why don't we just rewrite it to be powers? 4 over x cubed can be written as what?
4 to the negative, well, 4x and -3.
Square root of x can be written as x to the what?
1/2.
1 over cube root of x.
-3/2.
Negative what?
3/2.
1/3.
Oh, because it's a cube root, not, yeah, never mind.
It's not the square root cubed. Oh, now that's real simple, right? That's just simple sum, power, scalar equal. What is that second term? And what is that third term?
-7/3 x to the -4/3.
Positive.
Oh, positive. Little stuff.
If you ignore the minus out in front, yes, it's negative, but then minus negative. Now, remember I said about the general rule earlier? That's not the same form as what you were given. No negative exponents and no fractional exponents. There's your derivative. Oh, why not? Piecewise function. So we're going to take this by pieces. What is the derivative of x squared? What is the derivative of 2x plus 1? So let's call this question mark, because it doesn't tell us what happens at 1. So I'll put a question mark when x equals 1. Because we don't know. But we can figure it out. Call that the left-handed derivative at 1. Which piece is to the left of 1? Plug it into there. What do you get? That would be the right-handed derivative at 1. Which piece is to the right of 1?
2.
Plug in 1, what do you get? Are they the same?
Yeah. The original function is like a jump discontinuity, right?
But that is a jump discontinuity. So, unfortunately, the derivative does not exist. If it wasn't a jump discontinuity, the derivative would exist. That would be the derivative. Nothing at 1. If I can get through all this today, I'll be in good shape for next class. Class might be short then. Maybe they're gonna make it worse.
Is that, what's it called? Chain rule, yeah. I don't want to use the multiplication rule, so let's just distribute it. I love rooming, but
You know what the beautiful thing about math is?
what's everybody
What the beautiful thing about math is?
saying? I'm not as much.
It doesn't care about your feelings. Doesn't care what you want to do. So we are going to use product rule. I'm actually going to do both to show it off. But now you're going to use product rule, just you.
What if you chain rule with only the exponent out there?
Yeah, but I'm not there yet. I haven't taught chain rule.
I'll just make sure.
So none of these will require chain rule. So method 1 is product rule. Fortunately, if I didn't use product rule, we wouldn't actually get to see them in action until next week. So, we use product rule a lot. Even though, yes, you're right, you don't need to use product rule here. Product of two functions, so it's product. And again, I'm going to write it out for this one, and then probably not do it again. Order doesn't matter, but to keep it in line with quotient rule, g of x, in this case it's h of x, times the derivative of your first function, plus the first function, times the derivative of the second. What is the derivative of x squared minus 3x?
2x minus 3.
What is the derivative of x to the 1/2?
1/2 x to the negative 1/2.
That is unacceptable because that is not simplified.
X over 2
So-
squared x.
Simplify it. we have a common term, x. Factor out the lowest power. Which is -1/2. There are no other common terms.
One
Actually, I lied. There is.
x.
I don't like fractions, so I'm just going to factor out the fraction as well. You don't have to, but I'm doing it. So look at first term. The constant is 1, right? When you factor a half out of 1, what are you left with?
Two.
2.
Yeah.
When you factor x to the minus a half out of x to the half, what are you left with?
Wait, x is the thing.
Hmm?
Wait, x is the
X to the what?
thing. Minus out of.
And so x to the minus half out of x to the 1/2.
Otherwise.
Plus 1. So when you distribute, what's the operation?
Multiplication.
Isn't factoring the opposite of distribution? What's the opposite of multiplication? So when you factor out, you're dividing. It'd be x to the half divided by x to the minus half, which is the same as x to the half times x to the half, right? X to the first power. You can also double check by distributing back through and making sure you get the same thing, right? We didn't factor anything out of there. Ooh, oh, this one's going to be tough. You factor a half out of a half, what are you left with? Oh. No. I'm just being sarcastic. This shouldn't be that difficult.
1.
It's 1. Factor x to the minus half out of x to the minus half, what are you left with? 1. Means that the second term is going to be left with x squared minus 3x. Two over x to the 1/2, I'm going to leave it as fraction exponent because they gave me a fractional exponent. 2x times 2x
4x
plus x squared. Two x times -3
-6x.
minus 3x.
-9x.
There's your derivative. 5x squared minus 9x over 2x to the 1/2. That is using product rule. Second method. I don't want to use product. You should just strip that x to the 1/2 through right away. What What happens when you distribute x to the half into x squared?
Yeah. Yeah.
Minus 3 what? Take the derivative. What do you get?
5 halves x to the 3 halves minus 9 over 2x to the 1. Okay.
Where's the x? Is it in the denominator?
Oh, 9 over 2x to the 1 half. Sorry. No.
Then, again, the way you said it sounds like that.
Oh, 9 over 2 times x to the power.
Oh, right. It's because that's not fully simplified. I can factor out the x. It's actually really annoying. I'm actually going to ignore that and force it into the original form, which you can do. I'll do both. So you factor out, actually just combine like fractions. There you are, right away. Or you can just multiply numerator and denominator by x to the 1/2.
Don't you get over 2?
5 halves minus 9 halves. Common denominator of 2.
Gosh.
No, that's definitely not cubed, is it? All right, multiply numerator and denominator by x to the 1/2. And you'll get what we got originally with the product rule. So either way, it doesn't matter, right? Either product rule or rewrite the function and use the more basic rules. Yep.
No, quotient.
Is there another way to do it?
Isn't that cubed and squared?
Hmm?
Cubed on top and squared.
Well, that's true, but we're not doing limits, so that doesn't really help us. There actually is another way we could do this. We don't right now have the tool for it. I could perform long division on this and rewrite it, but that would require chain rule. So no, unfortunately, We have to use quotient. G of x times the derivative of f of x minus f of x times the derivative of g of x over g of x squared. What is the derivative of 2x cubed minus 1?
6x squared.
Derivative of x squared plus 4. And as a general thumb, just leave the denominator alone. Oh, now we get to simplify it. Six x squared times 6x squared will be 6x to the fourth. What about 2x times 2x cubed? 4x to the what?
To the fifth.
2x times 2x cubed.
2x.
Be the fourth power. Okay, so we have fourth powers. 6 minus 4. Uh, 6x squared times 4.
24x squared.
Negative 1 times 2x. Now ask yourself, does factoring the numerator serve any purpose? If I factor out a 2x, I'm just left with x cubed plus 12x plus 1. That is not going to factor to an x squared plus 4 to cancel out. So there is no purpose in factoring the numerator, so leave it. Serves no purpose to factor out that 2x. Even if x cubed plus 12x plus 1 factored, it's not going to cancel. So why go through that headache? Yeah, I'm just going to leave it like that. Now, if I was particularly neutral, find the second derivative. Would be easier with a certain rule we don't know yet.
Chain rule of the quotient.
But we don't have chain rule.
But I know.
It doesn't matter if we don't have it. You have to forget that,
Okay.
shock therapy to remove that memory.
I need it. It's like you don't have any number in your toolbox. It's like, oh, but I know what number looks like.
Just hope that the shock was, with my luck, I'd go to shock therapy, erase a certain memory, erase everything but that one memory I want to be erased.
If you were to start back, would you just multiply it, bottom of the quotient, and then?
What you have to do is you have to expand out the denominator first.
Yeah.
And then you use quotient.
back there.
Now, again, that's not actually a terrible expansion. But then you'd have to do the quotient rule, and then I could go, what's the third derivative?
Why would we do that?
Now that's an even worse expansion.
That comes forward with it, just say it, so it's not.
Oh, it's still math.
Still say it, so.
No, if that's the case, before I go any further.
So just 0.
Don't have to do any work. Right, the 124th. Actually, no, it's not. Is it? I think it is. It's not. Right, because after 124 derivatives, you're going to be left with an x. Right. No.
Third derivative.
No, you would get it.
X squared.
Yeah, you would get a constant answer 0. But
Get your factorials ready.
I'm 124 factorial times 10 to the 6th. So 124 factorial million. Oh, by the way, 124 factorial is a really, 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 really large number. I actually don't think you can do it on the calculator. I think it'll give you an error.
Yeah, it goes up to 68.
Yeah, I think 124 factorial will give you an overflow error. I don't, actually no, I do know for a fact that will function will give it to you. Pretty sure it gives it to you. Just some little tricks. Be really, really, really evil. Give you like the 1 millionth derivative, but be nice and make it a really nice function. Something like sine of x or something. No, we're not there yet though, but you'll see. Similar, we want value of a so that the slope at 1 is 6. Do I want to use product rule? Not really. But I probably should, just so that we get used to it. F prime, using the product rule. X squared times derivative of the first function, which is what? Plus x plus 1 times derivative of x squared. Ooh, that's nice. I'll get a 3ax squared, right? Plus 2x. That has to equal, or actually that at 1 has to equal 6, right? Evaluate that at 1, what do you get? So it has to be 6. 3 has to be 4. So a is 4/3. Equation of the line tangent to that hideous thing at x equals 2. First we need y prime. What order do we have to use? Yeah, quotient. X minus 1 times the derivative of x squared minus 5x plus 6, which is what?
2x minus 5.
Minus the numerator. Now times the derivative of x minus 1. Well, at least that one's not too bad. All over x minus 1 squared. Oh, calculus is done. That's algebra. At least this isn't too terrible either. 2x squared minus x squared is x squared. Negative 2x minus 5x is negative 7x plus 5x minus 2x. We have a 5 minus 6, so minus 1. No way.
Wouldn't it be negative 11, negative 1?
You're right. I knew something was wrong because that looked too nice. No, it's not. Right, because it's negative 5 times negative 1, which is positive 5. Positive 5 minus 6 is negative 1. Either this is wrong or I am wrong. Which one is it? 2x squared minus x squared is positive x squared. Negative 5 and negative 2 is negative 7. Negative 7 plus 5 is negative 2. Positive 5 minus 6 is negative 1. So that should just be 1. That's I plug in 2 without doing all that. That's 1, 4, that's negative 1, minus 2 squared is 4, minus 10, over 6, that should be 0. Over 1 squared. Yes, that should be negative 1. Oh, no. Come on, I am being a dumb. Now it doesn't factor. That's a -1, not a +1. I'm back. Had a little bit of a brain fart. Happy nights of Monday morning. Plug in 2 right there. Four minus 4 is 0. Minus 1 is -1. Over 1 squared. Slope is -1. Negative x. Y at 2
Oh, that's-
is 0, right?
Yeah.
Times, or plus, -1 times 2. Remember, it's minus that, minus a f prime of a. So minus -2 plus 2. There's your tangent line. What are we looking for? I'm not doing power rule. That's just what x to the 3/2. S prime.
3 x root x. Oh, yeah, 4 prime.
S double prime.
3/4 x to the -1. Yeah.
You don't want to simplify that part, David.
There's your second derivative. And that took a whole of, what, 5 seconds?
Yes.
We have to use quotient rule. If it was the reciprocal, we wouldn't have to. So denominator times, what's the derivative of the numerator?
3x x over
Minus the numerator times the derivative of the denominator.
2x.
All over denominator squared.
Wait. Quotient rule is denominator first.
It is.
Oh, yeah. Wait.
That's what it is, right? Denominator is x squared plus 5 times derivative of the numerator.
Oh, yeah.
Algebra. That's what 3/2 x to the 5/2 plus 15/2 x to the half minus 2x squared. x squared times x to the half is x to the 5 halves, right? And x times x to the 3 halves. I'm sorry, that's not x squared. I was thinking it was half times 3 halves. First part, that's 5. That's x to the 5 halves. Oh boy. 3 halves minus 2 is what?
-1.
And then just get rid of the compound fraction, multiply numerator and denominator by 2. $15 x to the half minus x to the 5 halves all over 2 quantity x squared plus 5 squared. Right. Again, you could factor the numerator, factor out that x to the half. Let's see what purpose it serves, so I'm not going to. Power rule, constant rule, sum rule, scalar multiple rule, product rule, quotient rule. Any questions? Pretty easy. Your second group assignment's available now. I don't know if you're able to do it yet.
No,
I think you need at least chain rule. Oh wait, that's right, no, because I'm also going to have you do trig function. Yeah, so you're going to need at least chain rule to do the inverse, I believe. To even derive the formula for the derivative of the inverse, you need chain rule. And then some of those functions on there you're not going to be able to do until we do the trigs and the exponentials and logarithmics. Chain rule is next week.
No.
So you should be able to at least start it next Tuesday after class.
Is it the same format as the last group assignment? No.
It's not using Wolfram.
Okay.
So this is going to be purely typed up.
Okay.
It's a proof, derivation, and then use the formula that you're deriving to calculate subtle derivatives.
Typing or writing it on a piece of paper.
Typed.
Type.
The group projects can only be typed. You can do all the work on scratch paper before you type it up, but the final result has to be typed using something with math typesetting. Right, so again, if you're bold,
You can use Wolfram though, right? I think Wolfram has a section.
Wolfram does serve as a typesetting.
I know they do.
I don't know how the online one works. I don't know how well that works. I know the desktop version, so I can use it.
Word is easy.
It works pretty well.
Word is the easiest one to do.
Word and Google Sheets,
Word is-
Google Doc would probably be the easiest ones to use.
Yeah, Word is the easiest. You just really write.
But Word is not really that nice professionally. Because it's typesetting, and the professional format is not that good. But it serves your purpose. So get into your groups.